Hello, math students, from Mrs. Marcellus and Gottlieb, the graphing guru. In this lesson, we're going to describe the shape of data distributions. Today's learning objective is students will describe a data distribution by its center, spread, and overall shape by analyzing and interpreting various data displays. Today's vocabulary: data distribution. This is the arrangement, the shape and spread of the data values. There are many different ways we can describe the shape and spread of the data. One word we use is gap. A gap is a number or interval that has no data value. Cluster is data grouped closely together. Peak is the most frequently occurring value or values. This would be the same thing as the mode. Symmetric means that data are evenly distributed between the left and right side. If we have symmetric data and all the values of the data set are known, we can use the mean to describe the middle and something called the mean absolute deviation to describe the spread. The mean absolute deviation is found by calculating the distance of each data value from the mean and then finding the mean of all those numbers. Basically, it's the average distance the numbers are from the mean of the data set. If a data set is not symmetric or asymmetric, and all the data values are known, we will use the median to describe the middle and the interquartile range to describe the spread. What do you say, Gottlieb? Shall we take a look at some different data distributions and describe them? Let's describe the shape of this line plot and identify appropriate measures for the center and spread. There are lots of different things we can say. Here are some examples. The data is not symmetric. It is not evenly balanced between the left and the right. There is a peak at 12 states visited. This would be the mode of the data set. There is a cluster of data from 10 to 14 states, and there is a gap in the data, a place where there are no data values, from 15 to 18 states. It appears that 19 states is an outlier. Since we do know all the specific values in this data set and it is not symmetric, we could use the median for the measure of center, and we could find the interquartile range for the spread. Let's take a look at another example. Let's describe the shape of this distribution and identify appropriate measures for the center and spread. In this example, the data is symmetric. If we draw a line right down the middle, we can see that the data is evenly distributed between the left and the right side of that line. They're a mirror image of each other. There are peaks in the data at ages 28, 29, and 30. These would be the three modes of our data set. There are no gaps or outliers. Since the data is symmetric, we would use the mean for the measure of center, and we would calculate the mean absolute deviation, or the average distance each data point is from the mean, to describe the spread. Let's describe the shape of the data distribution for this box plot showing the number of text messages sent. Since both boxes are the same length and both whiskers are the same length and the median divides the data right in half, we can say that this data is symmetric. There are no outliers in the data set. The median number of text messages sent is the dot right in the center of the plot, and that is 25. The interquartile range is Q3, which is 40, minus Q1, which is 10, or 30 text messages. Since we don't know the specific values that make up this data set, we are unable to calculate the mean or the mean absolute deviation. This box plot looks quite a bit different from the previous one. It is clear that this data is not symmetric. There is an outlier at 20 pounds. The median weight of dogs is 160 pounds. The interquartile range, or Q3 of 180 minus Q1 of 120, is 60 pounds. Because the left whisker is a lot longer than the right whisker, we can say that there is a much greater spread in the lower 25% of the dog weights compared to the upper 25%. Again, we don't know all the specific values that make up this data set, so we are unable to calculate any other measures. Let's describe the shape of the distribution in this histogram. There are many things we could say. Among them are, the data is not symmetric. There is a cluster from 0 to 49 minutes. There is a peak on the left side of the 20 to 29 minute interval. The reason I say the left side is the frequency for the 10 to 19 minute interval is higher than the frequency for the 30 to 39 minute interval. There is a gap from 50 to 89 minutes where there is no data. And there was one person who had to wait in the 90 to 99 minute interval, and so we would call that an outlier since it's removed from the rest of the data. With a histogram, we also do not know the exact data values that make up the set, so we are unable to calculate any of the measures of middle, such as mean, median, or mode, or things like the interquartile range. Well, Gottlieb, aren't you glad we didn't have to wait in line 90 to 99 minutes to get into the concert last night? That certainly wouldn't have been much fun. I did once wait in line over 4 hours, though, to get tickets for Garth Brooks, but that was before people bought all the tickets over the internet. Well, math students, this concludes our lesson on the shape of data distributions, so we're signing off for now.